Hello everybody, today we're going to be talking about the balloon geometry. We're going to use the balloon geometry to represent molecular geometry, and to embark on this, to do this, we use the valence shell electron pair repulsion model, which the electrons we're going to represent this sides to be the electrons, while the middle is going to be the atom nuclei. And we know for a fact the atom nuclei, which is going to be the middle, is what bonds together, and the electron, which undergo repulsion, are going to give themselves distance due to this repulsion, and due to this repulsion, they form some sort of angle. So in this sense, we're going to have these two balloons to represent like the first bonding, and we're going to see the repulsion and what it's going to give to us. So just sit tight while I do correct. So let's assume there's been a bond formed. We get to find out that the electrons are going to repel themselves, and they're going to form a linear, like a straight line, which is going to be a linear. And due to the straight line, looking at geometry, we know a straight line is going to be 180-degree, which from the geometrical part of it, we know that this is going to be an AB2, which this is going to be an A, and this two end is going to be a B. So let's go ahead to form the BF, or let's say AB3, where you have more than just this bond right here. So let's go ahead and add the third one and see what's going to happen to the bonding angle and the repulsion. Okay, now if we look very well, we see that there's formation of a trigonal plane having three balloons together, and the bond angle of this is going to be 120. If you go back to the geometry in mathematics, you see this is going to be 120, and it keeps going forth like that. If we go ahead to add a fourth balloon to this, we're going to have a tetrahedra, which is going to be 109.5. So go ahead and try to add a fourth balloon to this. And see what's going to happen. So it stays this way, which now we have a 4 balloon right there forming the tetrahedra, which is going to show that this is going to be at a 90 right here, and it's going to be at a 120. So this is a tetrahedra. This is how it's going to look, and it keeps on going like that. If you add the 5th balloon to it, is going to form a trigonal bipyramid, which is going to be the 90 and the 120. But let's not forget that in the case of where you have a 4 balloon, is going to be more of 109.5 as the bond angle due to the repulsion from the electrons. But let's not forget that the nuclei are centrally bound together. That'll be it. Thank you.